video, I'm going to show you the different types of geology that gold can be hosted in, look at some old drift mines and alluvial deposits. All that and a whole lot more coming up! Southern Nevada. Seen better days. Compressors, everything's set in here. That would be where the workbench was. And you can see where they had the tool room. Here's one of the machine shops. They also had another compressor. So you can see the timbers that they were using in here. A lot of it's falling apart. Here's your ore bins. You've got 2 of them for classification. And then there was another section right here that was attached to this. This was all encased at one time. There's your steps going up to the top of the ore bin. Top of the structure. There's the head frame. Still has the sheave wheel on it. Beautiful timber work. Look at that. Of course, you got a plug here. And you can see down inside. And there's the locking mechanisms there. And then the skip car would ride up. All the way up, and then it would dump all the way at the top. Back into the skip car would rise up, while the front of it would dip down. Still got the hoisting drum too. Now the host rock for this particular mine was porphyritic andesite, which looks like this, gneiss, and hornsfell. Now hornsfell is nothing more than cooked mud. We're in a hard rock gold producing district, which means that the gold was locked up in hard rock. It wasn't placer, it wasn't out on the surface, eroded away from the host veins. Now what's important to note here is you need to know your geology for each gold mining district, because each one is going to be different. And in this particular area, you had 2 types of rock that were generating the gold. In this particular area, this district, you had quartz monzonite. Now don't let the name fool you. Quartz monzonite is in the granite family. It just means it's granite, but it doesn't have as much quartz. I know, it sounds weird, huh? Why would they call it quartz monzonite? And you had andesite right here, and the 2 were coming together. There's a fault that runs through here. That's why you have to understand faults and geological maps and understand all of that, because you're gonna find a lot of your lode deposits where there was faults, and there's a reason for that. It's no fault of your own. What would happen is, it's been hydrothermally altered, and what it does is it alters the andesite, and you can see that here. It turns it into what's called propylite, and they were finding a lot of the stringers inside of the propylite where it's been hydrothermally altered, and the stringers look like that. They're tiny little stringlets, quartz veins, and if you get a lot of them, they're called stockworks. And they were finding trace amounts of gold inside of these small little stringers. Along the way, they were finding silicates of copper, which is chrysocolla, and they were finding carbonates too, which is always a good mix when you're in a gold producing district. Now, why am I showing you this? Because you're gonna need to know the types of rocks for each district, because that's gonna tell you where to look for the gold when you go out there to sample the mine dumps, when you're looking around to try to find your own outcropping, when you're trying to locate with a metal detector what type of host rocks and what was the gang material. Gang material is just the waste material that the gold's traveling in, like quartz or calcite. These are things you're going to need to know, because the USGS reports, which is filled with tons of information, is going to have that in there, but it's going to be written in that language, and you need to know that language. So when they say propylite, you're going to know it looks like this. It always looks like this. It's just like the stuff that you see in Bodie or Virginia City. It's been hydrothermally altered. And you're gonna need to know what andesite looks like. And it's an extrusive rock, intermediate extrusive. There's placer deposits, which are referred to as alluvial or eluvial. Eluvial just means that it's weathered away in place, probably next to the host vein. And alluvial means it's washed down. Water courses have brought it down, erosion, all that down into the water streams. So that's what you look for down in your washes. Alluvial. Eluvial is usually up on a hillside somewhere. So what I'm gonna do is I'm gonna take you over to an area that has alluvial gold, and I'm gonna show you what that looks like in conglomerate and some of the beginnings of a drift mine, because I think that's important in case you come across it, and that way you'll know what to look for and what to sample. So you know what I'm gonna say, huh? Oh, you better. So come on, let's go! Yee-haw! Brum, 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 brum. All right, now this is a old Model A, Model T. I don't know, maybe it's from the 20s or 30s. But I remember coming out here as a small boy, this thing was intact. It had the rest of it bolted to it, and somebody came out here and cut pieces of it off. Isn't that a shame? But when you come out to these old mining districts, you're gonna see cars like this. Look like I had a big straight 6. See how long that is? You ever wonder what the miners used to sleep on? Huh? Huh? Well, I'm gonna show you. Right here, you see that? That's a miner's cot. You can always tell because it uses this real spongy iron mesh, wire mesh. And they usually clip it on the front and the back. And it's actually quite soft. I've laid in these things before. And they're really comfortable. They're usually up on legs, but you can see the frame. And if you notice the size of it, it's about my size. Which will indicate what? The miners were about my size back in the day. But I wanted you to see what the old beds look like because I've never seen anybody talk about that. And I've seen these things intact in some old cabins before. All right, enough jaw jacking. Let's head on out there because I got to show you some of that conglomerate drift mining. So come on, let's go! Ooh, now take a look at this. Now we're in a gold producing district. That's rule number 1. And we're out here in one of these old washes that cuts through all this alluvial material. And you can see where it looks like an old timer come in here and he started punching into this stuff because he was looking for the mother lode, I tell you. Well, why is this important? Well, it's simple, really. Because if this has got somebody's interest, that means that they were finding something because they wouldn't dig a hole. At least maybe they found enough that would keep your interest. So what I would recommend and what I'm going to do is I'm going to come in here and I'm going to sample. And that's what you should do too. I'm going to bring in a 5-gallon bucket. I'm going to collect material from different zones. Then I'm going to go ahead and pan it out. If there's any gold in that sample whatsoever, I'm going to come back and I'm going to be a little bit more methodical about where I sample. So I need to localize what's called the pay streak. Sometimes there's multiple pay streaks, not just one, but sometimes different time zones of deposition. You have to know this. So what I would do is I'd get in there to try to localize it, and I'd also expand on it to see if there's more pay streaks in there. So what I want you to do is when you come out here to areas that are known to have gold in these old alluvial gravels, and you find one of these diggings like this, I want you to go in there and sample it. And like I said, do a bulk sample. A 5-gallon bucket should be plenty. You're going to get it all from the edges here, down around the bottom, you're going to get the slough out and get to the bottom of that. Put that into a 5-gallon bucket, take it, classify it through a 1/4-inch screen, pan it out with some jet dry. Take a look at it with a jeweler's loupe and see what you got. Now, if there's gold here, that means it had to come from where? From a source, that's right. And what you can do is try to localize that source by going up into any of the surrounding hills or mountains. Now keep in mind that you have erosion. And erosion's going to wear down those mountains into small hills. So don't think the source might still be there. It might have disappeared 100,000 years ago, maybe even 1,000,000 years ago. It's hard to tell based on the deposition unless you know for a fact if it was Precambrian or what have you. So what I want you to do is become familiarized with the types of rocks that are in gold producing districts. Now in this particular district, I've got a lot of Precambrian schist. Now schist is nothing more than shale that has been squeezed and heated. All right, and of course you know where shale comes from. Shale comes from mudstone. It's a clastic rock, and as it's pressed and squeezed under low heat, you'll start to see mica form in these sheets and bands, and sometimes you'll get pyrite crystals growing in between these sheets as well. A little bit more heat, a little bit more pressure, and it's changed into what? Slate, which is a metamorphic. So it has gone from sedimentary to metamorphic. More heat, more pressure, and then what happens? It becomes a piece of schist. Now schist is easy to identify because it's full heated, and it usually breaks apart real easy. And you can see where a lot of the mica is starting to form in the foliation. Now, a lot of times you can also have gold that will form or pyrite that will form in the foliation. Now, why is this important? Because a lot of times in your USGS reports, they're going to say there's Precambrian schist, and right next to it, you have quartz. This is nice blue quartz, and you can see where the schist was up against here, and then broke away, and you can see I've got what? I've got oxidation going on in there, probably from magnetite, and probably I've got also limonite in there. And that's what happens when a lot of your pyrite oxidizes, is you get limonite. Now, that's great news because you want the sulfur to go away. You don't want to have to roast it. You want Mother Nature to roast it. So when you see that red, it could be limonite, which is good because the gold will be left behind, or it could be oxidized hematite or magnetite. So I would be checking along here with a jeweler's loupe or maybe a Falcon MD20 or something like that. Now, there are other pieces of quartz out there. This is called bull quartz, and they call it bull quartz because it's barren. There's nothing in it. You see that? But it is a good indicator if you see an outcropping of this, especially in this area. And along the joints of the quartz, sometimes you can have mineralization in there. You see that? Where it's oxidized out. This is a good place to be running your metal detector over to see if there's any small traces of gold. Or you can crush it up in a mortar and pestle. Or if you got a small, handy portable rock crusher, you can grind it up right away. Put some jet dry in there to break the surface tension. Pan it out. So that's what I want you to do. These are some of the rocks you're going to see out here. And I thought you'd get a kick out of looking at some of them. 3 types of rocks. And I told you this. Sedimentary, metamorphic, and igneous. And a lot of your gold is going to be found in what? Metamorphic rock, a lot of it. And of course, most of your basement rock, your continental crust rock, is going to be igneous. And then of course, sedimentary, if it's under enough heat and pressure, turns into what? Metamorphic. You see how that works? And also keep in mind that you got 2 different types of sedimentary when you're talking about limestone and shales, okay? One is clastic and one is bioclastic. Bioclastic just means it's got a whole bunch of seashells and living organisms that make it up. That's what limestone is. And this stuff is just plain old clastic material that's been squeezed like mudstone. And it's turned into this. A little bit more pressure, it becomes what? A metamorphic rock. And that would be slate. A little bit more pressure becomes what? Schist. A little bit more pressure, it becomes what? You better know this, come on. So, and then of course, you have all different variations. I could go on and on about this. And then you've got all different models of deposition. But at least know your basics when you go out to a gold producing district and know what the rocks look like that are hosting the gold, okay? So anyway, I'm gonna get out of here because I'm gonna sample this real quick. And I'm going to see if there's any gold in it. But before I do that, I need to go on to mylandmatters.org and see if there's a claim here first, because I don't want to be claim jumping and stepping on somebody's toes. And that's what you should do too. And their reports work with LR2000, the BLM report, and they're updated every 2 days. So that way you know the information you're getting is accurate, and then you can tell if that land is open or not. And I've done videos on that, and I'm going to do more videos on it. So anyway, I'm going to get on out of here, because I got to get my bucket and I got to sample. Because I got to have that gold. Woo, yeah! You know what I'm going to say, huh? Woo, you better. So come on, let's go!
Jeff.